Hey there once again, YouTube. So, just something real quick. We're going to talk about Yellowstone today. There's an increase in seismicity just south of West Thumb Lake. As you can see right here, there's a linear path. Notice this. Almost a line of earthquakes taking part in a rapid-fire swarm. The last rapid-fire swarm for the Yellowstone area was, I believe... Actually, why don't we go check it out just real quick on my website. I believe it was May 23rd. I believe it was. Let's just check just real quick. Let's see, go to seismic events, drop down menu, by location, Yellowstone supervolcano. And I will create an analysis page for today's earthquake swarm. That'll probably be up by tonight. So May 28th was the last rapid fire swarm that we saw. But this type of swarm that occurred today has not occurred for a little while. A lot of the rapid fire swarms lately have been pretty minor. Pretty minor, except today's probably was, I'm going to say, just as strong or stronger than the January 23rd, 2019 Shoshone Lake, Lewis Lake swarm, possibly maybe even before that. So it has been a little while since we've seen a good sized rapid fire swarm. I'm going to label the severity as moderate because it's not a major swarm, but it's not a minor one either. So keep an eye out under the seismic events drop down menu on my website by location, Yellowstone supervolcano. My analysis page will be up tonight. We're going to take a look at earthquake counts. Right now they are reporting for this earthquake swarm about 14 events. There were two other earthquakes that, let's see, there's one at 8:35 just after the swarm far to the west. And there's one right here that occurred during the earthquake swarm that was a little bit farther north, but the majority of the swarm occurred in this patch right down here. Turning on US faults. Not seeing any faults labeled for this area, but of course there's probably faults all... Oh, nope, never mind. Never mind, there is a fault right here. Notice it takes the same path as this fault. Let's see. And remember, faults can act as weak points in the crust, just letting you know. East Mount Sheridan faults. Now, let's check out this. Notice you can see showing up on multiple seismic stations across Yellowstone. See that? Multiple twos, I believe. There are multiple twos, and also Steamboat Geyser just erupted, so we're going to be talking about this today. Just those two things, just real quick. First off, for the earthquake swarm, again, about 14 events were reported. The most shallow event reported for the swarm was 2.3 kilometers in depth, and the deepest event of the swarm was, let's see, was this one right here at 6.4 kilometers in depth. So between 7 kilometers and 2 kilometers in depth. So pretty shallow, guys. That's pretty shallow. Remember, 0 kilometers in depth is supposed to be sea level, just so you know. And let's see, the largest reported event for this swarm was a 1.7. Surprisingly, I thought there were going to be multiple 2s depending on how far they traveled, because some of the earthquakes showed a Mary Lake, YFT here at Old Faithful, even probably a little bit farther than that. So I thought that was kind of interesting. So let's go check it out in the seismic program swarm, just real quick, from the closest seismic station, which would be this station right here, borehole 944. If YMS at Mount Sheridan was working, then I bet this station would be the closest seismic station, but as you can see, it still is not working. Like, it has not been working for, I'm gonna say, maybe a year. I mean, it's been a long time since YPP and YMS have been offline. I am begging University of Utah, please get them back up and running. That would be wonderful. Here we are with the most recent data from borehole 944 in the PB network. No location code given, which would mean it's -- if you want to download the data yourself. Short period vertical, EHC, meaning we do not need a frequency filter. I do not want one right now. This is the rapid fire swarm that occurred today. Let's use the spectrogram at first to see if there are any low frequency events. That's the first thing I do, guys. The very first thing I do when analyzing any earthquake swarm, even in non-volcanic areas, I still always check for low frequency tremor and low frequency earthquakes to see if anything indicative of fluid movement or magma movement. I mean, of course, it's not required. You know, magma intrusion can happen with very little low frequency tremor and low frequency earthquakes, but that is a telltale sign that I always like to look out for. Here's the swarm right here. You can tell there are many events, many more than just 14, guys. I mean, look at that. Those are all earthquakes. All of those are earthquakes, guys. Let's zoom out just a little bit. Notice that? Here's the first burst in seismicity. And then it calmed down. Let me zoom in just a little bit. Then it calmed down for, I'm going to say, maybe 30 minutes or so. few microquakes here and there, microquake, and then boom, then we see another burst in seismicity. Although the first episode up here was probably twice the size, probably twice the size as the second burst right down here. And then we had a few little more aftershocks after the swarm, but that's pretty much it. But you could tell there were many more, many more than just 14. We're gonna do a quick count. Oh, by the way, on my analysis page that I'm putting out tonight for this earthquake swarm, I will include the seismic audio, so look out for that. Now, this is just a rough count. I will probably do a more accurate estimated earthquake count tonight in the analysis page, because really, when these rapid fire swarms happen, only a small, minute percentage are actually reported. Very tiny, minute percentage. So, we see 1, 2, 3, 4, 5, 6. Remember, this is just preliminary. This is not for sure. 7, 8, 9, 10, 11, 12, 13, 14, or 15. No, I'm going to say 14. 15, 16, those look like two separate quakes. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, whoops, 28, 29, 30, 31, 32, 33, maybe 34, 35, 36, 37, 38, 39, 40. Remember, I'm counting all magnitudes, even the tiniest ones. Where did I leave off? 40, right? Then there's 41, 42. There's probably a little more microquakes, but I'm just gonna do, 43. 44, 45, 46, 47, 48. A lot of them are small though, very small. 49, 50, 51, 52, 53, 54. Those are definitely two separate quakes right there. 55, 56, 57, 58, 59. Wow, I'm gonna say 63, 64, 65, 66, 67, 68, 69, 70, 71, 72. And then that's pretty much it, 73. So I'm gonna say maybe around 75 microquakes of all sizes. But the largest, I'm gonna probably agree with them. The largest is gonna be a 1.7 or so, which I believe, let's see, which one's the largest? I believe this one was the largest right here. Check out the amplitude count. Yeah, that definitely looks like a magnitude 1.7. Downwards going P wave, showing dilatation, which is very interesting. And yeah, the largest one was this one right here. Right there. So I will be doing an analysis page tonight with in-depth plots for most of these events, probably all of the events in this earthquake swarm. Again, only 14 have been reported for the larger earthquakes, except they do have some negative magnitude earthquakes that they have reported, which is strange. So if they can report the negative magnitude ones, then why didn't they report the other ones? Some of them do not have clear P and S wave arrivals in surrounding stations, so I do understand that, because in order to locate and accurately locate an earthquake, you have to have 3 seismic stations with clear P and S wave arrivals. Otherwise, you won't be able to locate it, because they use a thing called triangulation. You got to triangulate where that is, and you got to make a triangle, right? With 3 stations. The more the stations, the better, though. I mean, you can use 5, you can use 6, but typically you should not accurately locate an earthquake with less than 3 stations. You need 3 stations. Repeating myself, but it's true. Then a few more quakes after the swarm, so that's very interesting, guys. We did see a rapid fire swarm, the largest one that has occurred at Yellowstone for a good few months now. It wasn't too crazy, it's just a moderate rapid fire swarm. Remember, on my website, I do have that rapid fire swarm earthquake page for West Thumb from 2014 to 2018. 2018 saw the highest count of rapid fire swarms for Yellowstone caldera, primarily occurring around Shoshone-Lewis Lake, West Thumb Lake, and Yellowstone Lake. So that's very interesting how 2018 saw the highest count, although some of them were kind of minor. Some of them were kind of minor, kind of like the ones that we've seen in the past few months. But this one's very interesting. Again, we have not seen one of these in a good few months, maybe. Though I know the December 31st, 2018 one, the New Year's Eve rapid fire swarm, that one was major. That was a pretty large rapid fire swarm just to the, to the northwest of the northern tip of Yellowstone Lake. So, that's it for right now. Remember, go to my website, the Seismic Events drop-down menu, go to By Location, and monitor the Yellowstone Supervolcano blog page. My analysis page should be up tonight. It's going to be a little while though, because right now it's 1:09 p.m. Pacific Time, June 12, 2019. And I almost forgot, Steamboat Geyser did erupt. Let's scroll down. Oh yeah, you can see it definitely did erupt right there. This is YNM at the Norse Museum. And YNR, ever since the ground has thawed out, you can now see the steamboat eruptions on YNR as well. So why don't we go take a look at this from station YNM in the seismic program swarm. Also remember to go to the seismic events drop-down menu, go to buy event, and go to Steamboat Geyser 2019 to see all of the recent Steamboat Geyser eruptions of 2019. I also have all of the plots for all of the eruptions for 2018 as well. Again, this is on my website, link in the description box below, right under my email address. The recent eruption that just occurred today, I have not put on this page yet because it pretty much just happened. I just noticed it. I try to update this page as quick as possible when a new eruption occurs. So the last eruption was the 20th eruption in 2019, the 52nd eruption, but today's eruption was the 21st eruption of 2019, which would be the 53rd eruption since it reactivated in early 2018. Now the last one occurred on June 7th, and it is 2 days early again. So I was predicting, because it was holding, Steamboat Geyser was holding a pretty steady weekly schedule until June 2nd, 2019. That's when it broke its schedule and started erupting 2 days early each time. The past 3 eruptions, including today's eruption, have occurred in 5 days instead of 7 days. So it is possible it is starting to erupt more frequently. Just seeing the past 3 eruptions, don't know that for sure because Steamboat Geyser likes to change a lot. It likes to hold a schedule, trick you, and then change. So, because one time it skipped almost 2 weeks, a long time ago. I think that was a few months ago. So, June 2nd, 2019, then 5 days later, we had one on June 7th, 2019, and then 5 days later, today, about 5 days, we saw the 21st eruption of 2019. And again, I have not updated this for the most recent eruption today, but I will do that in just a little bit. Why don't we take a look at the most recent eruption in the seismic program swarm. Here we are in the seismic program swarm with data taken, the most recent data actually, as of 1:13 p.m. Pacific Time, June 12th, 2019. We see the eruption started right around here. It's kind of hard to tell. I'll have to take a closer look, but I believe the eruption started right here, right at about 1852. I was going to say 1853, but you can tell it starts to increase before that. So at the end of 1852 UTC. So that's, I'm going to say, let's see, that's 11:52 a.m. Pacific Time, so that's almost 1 p.m. Mountain Time. So, very interesting. Let's go to the spectrogram, shall we? Let's zoom out even more. Now, all this right here, I do not believe is connected, because I've looked at it. It's occurring every single day during the daytime hours from 7 a.m. to about 6 or 7 p.m., which is the same time frame that people are in the museum, excuse me. And trust me, it's very active right now. There's a lot of people at Yellowstone right now, guys. It is summer, it is tourist season, and they got a lot of people there. So probably a good amount of people got to see this steamboat eruption. But a lot of this stuff, in my opinion, has nothing to do with steamboat. Maybe some of it does, but in my opinion, it does not, because it does not correlate usually with the steamboat eruption. Sometimes it does, sometimes it doesn't. And a lot of these sometimes look like footsteps, for example. Let's take a closer look. See the extreme high frequencies and no PNS wave arrivals. Notice step, 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 step. Someone walking away. Those look like footsteps, right? And if you, and the seismic station is inside the museum. So really, we should be picking up a lot of people there because it should be pretty packed today, guys, especially the next month or two where it's summertime, it's vacation season. So let's go right here. Again, Steamboat Geyser erupted once again. Going forward, here's the eruption. Started at about 1852 UTC. Going forward, it lasted a good amount of time, guys. A good amount of time. Longer than an hour. At least the seismic trace lasted longer than an hour. But the main burst of the eruption, I'm going to say probably lasted 45 minutes to an hour, maybe. Something like that. So, very interesting, guys. I will put that on my website under the Steamboat Geyser page. I will do that right after this video is done. And also keep an eye out for my analysis page tonight about the rapid-fire earthquake swarm that did strike Yellowstone this morning. Or was it last night? I don't know. Hold on, let me check. What am I doing? What is that? Oh, that is last night. That's around midnight last night Pacific time, so around, I'm gonna say maybe 1 a.m. Mountain time. So it was last night, definitely. Alright, well, I hope you guys all have a great day. Let me know what you think. God bless, and keep an eye out for my stuff. See you later.